of what I've learned in Keystone is the general practice that is role-based access control. And so what I'm going to try to go through today is to extrapolate from what we know in RBAC in Keystone and talk about it across multiple systems. So there's going to be some OpenStack specific stuff, and there's going to be some Kubernetes specific stuff, and I'll use different code names like Manage IQ and Cloud Forms for third-party applications and all that. But this is a general structure of how to think about RBAC, and it should apply across most of the technologies that you're going to hit. Now, I haven't put my slides on the big screen yet, so I don't know how legible some of these are going to be. This one is the one that's the worst with the most printing there. But what I'd like to read here, in case anybody has there, this is a quote from a friend of mine. Being a former Army officer, which, by the way, I am as well, and so this is near and dear to my heart, who now works in the civilian world, it means that when I was 25, I was trusted with individual weapons, rifles and pistols, live ammunition, $80 million worth of Patriot missiles, I didn't have that much, $200 million worth of military vehicles, equipment, hardware, the health and welfare of 25 other adult humans and their families, and accountability for almost 600 other adult humans. And now that I'm 48, I'm not trusted with the administrative privileges for a smart sheet. And so that's from Dennis. Actually, the picture is also from Dennis's personal collection. And Dennis was in his mid-20s when he was in that role, and he's in his mid-40s now. And the difference is the Army as an organization is designed to scale, and a lot of the organizations that we're in now don't have that structure in place. And that's what we're going to talk about. And that's why the subtitle of my thing was how to scale the capabilities of your organization, because that's what RBAC is there to do. Now, we have a lot of really smart people here, and that's a problem. The problem is that people don't scale. There's an old quote off the Linux mailing list that Linux doesn't scale. And we have, how many people have read the Phoenix Project? It was kind of required reading for here. Okay, so I'm alluding to that here. We have in the front Brent, and Brent was the really smart operator in this book, The Phoenix Project. And the problem is that Brent became, by being the person who knew how everything worked and could make everything work, he became a single point of failure. And he became the constraint. And so Brent was essential to get anything done, and anything that was not required, because Brent couldn't get around to do it, it was forbidden. Well, some people didn't like this, and what did they do? They worked around Brent. They set up shadow IT. Oops, right? Because the shadow IT isn't the problem. It's the big expose that happens when your shadow IT is no longer in the shadows. And it's not good enough to be smart. What you have to do is figure out how to let other people be smart, but do it safely. So delegation, that's how the Army works, and that's how things work. The power that you have comes from somebody else, and it comes on down. And in my company, it goes, in most companies, it goes from the stockholders to the board of directors, CEO, my VP of sales, my director, my manager, and down here you see Adam. Everything I do is delegated to me from up there. And I am only one of over 10,000 people in the organization. Large organizations can only exist if they delegate, okay? So what we know from the real world has to be able to apply to software. So I'm here to talk about role-based access control. I'm going to give you a little bit of an introduction of what this really means. And I'm going to try to give you some visuals to go along here. And probably one of the best roles that we know about is a doctor. A doctor is somebody that we trust to do special operations. Things that we would not do to ourselves, we let doctors do to us. If you play the doctor role, then you can do these things. And that's what we have here. A role is a label for a user. And if the role matches, you have the right role for whatever the operation is that you want to do, then you're allowed to perform the operation. That's the simple, basic operating factor of RBAC. And there's a big paper that actually defined this. Now this is where it first came from, but this is the one that the people refer to as far as what is RBAC. So let me talk a little bit about this concept of a role. And I'm going to use this using somebody that, how many people recognize the person in all these pictures here? Only one person recognized? 2, 3? Come on. I see a little bit. Okay, Ron Howard. We have Ron Howard in 3 different roles as an actor in the first 3 pictures there. But he's played multiple roles through his life, not just as an actor, but you can see in this picture to the right, this is from his wedding. Some paparazzi snapped it. He's playing the role of groom, and you see there's a ring on his finger. He's in the role of husband now. In the bottom left, we see him in his director role. Because he's a famous director, he's often invited to red carpet events. What role is he in there? Is he in his director role? No, he's just a guest. Maybe he's an award recipient. Maybe he's even the presenter. What he's allowed to do in this event depends on what role he's in there. And I have this last picture here because he's not actually in the director role here, but he plays this role because he is a successful director. In this role, he's a teacher, and he's teaching other people there. So you can see that one person can play multiple roles, and whatever role they're in a given situation determines what they can do. And I'm going to go way over time. OK, so I want to talk about scope, because the role itself doesn't mean anything. It's the scope of the role assignment that matters. And what do I mean by this? Well, I want you to consider the differences between a couple of the roles and assignments that I have here. The governor of Illinois, the governor of Iowa, who, by the way, is Kim Reynolds, and I know that because I looked it up and put it in my notes, versus the governor of New York, Andrew Cuomo. What they can do depends on which state they're in. If Mr. Cuomo visits Iowa, he is just a visiting dignitary. In New York, as the executive, he has a lot of power. In both of these states, they also have a lieutenant governor. That's a different role, but within the same scope. And obviously, if the lieutenant governor of New York, Kathy Hochul, is in New York, then she has all the power of the lieutenant governor. She doesn't have it in Iowa. But we also have mayors of various cities that are inside these states. And so the mayor of Des Moines, by being in Iowa, is in one scope. And contrast that with the mayor of New York City, who may have a hell of a lot more power because it's a much bigger city. And then the mayor of Albany. Mayor of Albany and the mayor of New York City are both in New York State, but they're in different scopes within there. And to drive the point home, going back to our doctor analogy, only my doctor is allowed to work with me. So it doesn't matter if you just have the role of doctor, you also have to have that assignment to me in order to perform an operation on me. Okay, saying, I know you think, Adam, get back to technology. I'm going to get back to technology now. So what do we want to be able to do? What are the kind of things in the cloud that we want to be able to delegate? I got some use cases here. I don't actually have labels on the people who are trying to do these, but we can kind of deduce these. Some of the things that we all need to be able to do: deploy an application, scale it up under load or scale it back down, back up the database, and unfortunately, sometimes that means that we have to be able to restore the database. So we have a series of use cases that we need to be able to scale out, and we may not be doing these things ourselves. We may have automated systems do these for us, but they're doing it on our authority. And so this is what we need RBAC to let us do. And often these goes across multiple layers. And what I have here in poorly chosen colors, now that I see it here, is the layers of the basic stack that we're talking about here. We have our applications running in Kubernetes, maybe multiple clusters there, running, and we have an overcloud, which is our OpenStack deployment, and we have the bare metal that it's running on. And so anything that we're doing that's going to affect through all these layers has to have appropriate access at all these different layers. And we're talking about certain operations at the application layer, which is now, because we've added containers, it's now a layer removed from the virtual machine, so we have this indirection there. But it might need more storage, or it might need access to storage. So it has to pass through a layer, perhaps, to trigger an event to get more storage, or to affect a network change to be able to get communication with the other systems that it has. Virtual machines still are required for this because you may need compute isolation between different ones, or for the scale up, you may actually need a place to go. You may actually need to scale up your Kubernetes cluster to have more capability. And all these things require appropriate access. The thing that's supposed to ask for storage may not be supposed to ask for networking. I want to talk just a moment about federation. Because, when I say federation here, I really mean identity federation, because the word's being used for multiple things now. I have up here a document for Sally Sample. How many people here have a driver's license? Okay. What is the #1 thing that people use their driver's license to do? For what? To do what? To do what? Buy beer, thank you. Okay, so this document, which is nominally authorization to drive a vehicle, is most often used not in talking to a cop or talking to somebody or renting a car. You use it to do that too. Hopefully the cop one very, very infrequently. To prove your identity and an attribute about yourself, that your birth date is earlier than 21 years ago. Even, I don't know, maybe not here in Canada. And this is a form of federation. In the public, we use publicly issued documents to confirm identity. And within a company, we use our company-issued ID. We don't own, as the application developers, we don't own the user database. The users come from outside. And the nice thing about this is now it starts crossing layers. So when I go to Kubernetes or I go to bare metal, if I'm using one identity source, whether it's via LDAP or via SAML or something like that, I can use the same identity. And then it's just about what role I have when I talk to that system. And this is a really powerful thing. Now, along with that identity, just like in our ID case, Ms. Sample brings along her birth date, which is used to confirm her age. What other groups do you bring along with you? Are you in the over 21 group or not? And just about anything that could be done in an attribute-based access control system can be thought of as a group in the way that we talk about things in Keystone and the other systems that we're talking here. But it ends up being a flat namespace. And these groups are additional things that you can use to assign roles to people when the time comes to do operations. Okay, how many people here use Ansible? Okay, how many people here use it on their own system to like do something over there and get things done? Okay, I'm not saying exclusively, but I'm use that first. And that's how I got exposed to it. It's a nice tool, and I use it on my own machine to get access to remote systems. And so when I do that, it uses my credentials. It pretends to be me when I go there. But what happens if I need elevated privileges? I use the become keyword there, and now I'm acting as somebody else. This is a form of delegation, so I'm trying to get you oriented here to what we're talking about. This is the need to share and reuse these, this Ansible playbook gets taken to the next level. If I have a playbook and it's successful, and I'm a victim of my own success, then I need something like ManageIQ or AWX Tower to run this playbook, and now I'm sharing with somebody else. Well, I don't want them doing it as me. I don't want that work done in my account. It's my playbook. You can use your resources to do it. Or maybe I do want you to use my resources, but I want it to come from your quota. I want you to pay for it. Or maybe I just say, yes, you could do this today. You can do it for 24 hours. So I want to be able to make these kind of access decisions when I'm delegating from a remote system. And we have multiple remote systems that we talk about. A lot of what I got clear in my head about RBAC came from discussions with the Trove team, actually, which is an application that runs on OpenStack. It's an OpenStack project, but it's for creating databases within my project and within my quota. And it adds a lot of complexity to how these things work. And I don't want Trove to be able to do that based on somebody else calling it. I only want that if I set that up. And when I say I, it may not be me, but it may be somebody from my group. Okay, so somebody who has the appropriate role in my group should be able to use Trove to set something up. But what I have to do in these things here is I have to share my credentials. And that often makes me a little scared, because I don't want people doing things as me. I want them doing them as themselves. So this is a shortcoming that often comes up with how we set up one of these delegation systems to talk to our resources. And an interesting thing about this is that each of these adds their own layer of RBAC. Each of these has a role-based access control in there on top of what we had in Keystone. Now, Trove probably doesn't, because that's going to use the Keystone one for whatever it's set up on. But you could actually have a case that where CloudForms is talking to Ansible Tower to talk to Trove or Sahara to set up a Hadoop job or something like that. So you have these layers of delegation, and each has its own layer of RBAC and what it will accept. And so when one system calls another, it requires credentials on that remote system. These could be a single user, and a lot of times you see this. You just set up a user, and everything in Keystone is done as blah, or everything is done as the Keystone user. It could be the credentials of the person who called in there. It could be a specialized service account. Or it could be one that's like an account that you kick up that's based on the user. This is the best case. Based on the user, but with a lower level of credentials, delegation. Now, once that decision is made, it's going to be carried on through those links. So when Tower makes an RBAC decision, we can't go back to Keystone 2 steps later and say, oh, no, I want to be that original user. Once you go down that dark path, forever shall it dominate your destiny. And so this is the general rule. A little bit of trust goes a long way. The less you trust, the further you go. And yet, trust we must. So how can we do that? OK, so delegation. So here's my visual thing for a service user. I like the Roomba, because a Roomba is a service user. It's an automated system that we trust to do a constrained task. And we limit its scope, usually by walls and doors and these little sensors we put out there. But we can think of it as a service user. It should be easy to create a service user for something. Okay, and that's something that we've been really bad about doing. It's actually hard to create a user in Keystone. You have to have admin permissions, and that's an anti-pattern. In other systems, it's a lot easier. We have application credentials coming now in Keystone as a way to make that easier. But it's identifiable. Whatever system you're looking at, you want to make it easy to create a service user to do that, and then delegate. You provide some form of delegation mechanisms. I see some of the Heat folks here, and trusts, which are one of the primary delegation mechanisms in Keystone, was written for Heat and based on conversations with them to do exactly that, to do things on behalf of another user. So the trust only allows the trustee to do what the trustor can do. I can't elevate my privileges when I create a delegation. You want to say what I can do or less. That's the general mechanism that you use. And so let's talk about how you build a hierarchy of roles. And this is my own, I can't say this is my own, I got this from somebody else, but this is my own language to try to explain a way to think about it. And this is really the unified model that you're going to get into your head. So I'll use how many people have heard the expression, how many hats do you wear, or what hat are you wearing, and stuff like that. I use the icon of a hat there. You can see I kind of like my hats. To say, what's your role in the organization? What do you need to do to get your job done? What title do you wear? And in this role that you have as cloud solutions architect or software engineer or whatever it is, you have workflows, but you may not be the only person that needs to do these workflows. You may need to create a cluster to be able to do something for development purposes that I need to be able to do for demo purposes, but it's the same workflow. Create a demo cluster. So people in different roles do the same things, and those eventually have to resolve down to individual operations. And when I say individual operations, it's essential to remember that in most of the systems we're talking here, they're going to jump across system boundaries. We've got, going back to our stack there, if Kubernetes is doing something in the OpenShift layer, and that has to talk to the OpenStack layer below it, it's one operation maybe on OpenStack, create a virtual machine or something like that, but there might be a bunch of stuff that happens there. And so you should often think of what's one operation as what is the boundary at my system where I talk to another system. And so what do we get out of the box? We actually had a session not long ago where we talked about the default roles for Keystone, for OpenStack. And part of getting prepped for that and prepped for this is I said, well, let me look at the big three that I have to work with on a daily basis. What do we have for default roles there? So in OpenStack, we've only had admin and member forever, and auditor or reader or whatever we end up calling it. There's a little bit of bike shedding going on there, but some sort of read-only role. It's coming soon, and that's the big thing that people are beating up on us for. Well, if we look at the other two systems, we can see they basically have the same thing. OpenShift is a little bit more granular, and it gives us this basic user versus editor distinction, which I like, but it really maps pretty closely back to what we have over there. A lot of these have service roles, and if you do a if you do a grep that I have there, you can see there's a lot of service roles that are defined. So when we think about this from a service perspective, we're really granular, but we give users only 3 to choose from. So that's okay to start with. That's not a bad out-of-the-box thing, because we can't determine at the upstream level what you want to do in your cloud. How can you build your own? Well, I want to talk about one of the primary tools that you have, both in OpenStack and OpenShift Kubernetes. And I don't know how, again, I don't know how this is going to come to the big screen, but I guess it's not too bad. An implied role is, it's an inference rule. A implies B, B implies C, therefore A implies C. In this case, if admin implies user or member, and user implies reader, therefore admin implies reader. Well, you can define these yourself. And this is a really powerful tool, because these can then be nested. And these can be nested arbitrarily deep such that the stockholders have all the power of everybody underneath them. And the manager has all the power of the atom, and director has all the power of manager and atom, because the lower level role of cloud solutions architect is implied in the roll up to the manager. And so if you have some operation, and I use reboot as an example. I might have some system that needs to be able to read the state of a VM, and if it's dead, reboot it. And so I create this rebooter role that has, at the lowest level, at that API level, where it's remember, so it's jumping over system boundary, it has the ability to perform the reboot operation. And I say user implies rebooter. Now, user used to be able to do this by themselves, but now what can happen is user can say, I want to delegate just the rebooter role when I set up some service. So I can break a coarse-grained permission down to its finer pieces. And you can see when I set up a service user over there in Ansible, I just assigned it the rebooter role, because that's all I want that playbook to be able to do. And that's all I want that operation, the entire scope of it, limited on down to it. And let's talk a little bit what this means in building a hierarchy. It's called different things. I'm trying to give you a little bit of a Rosetta Stone here to translate between OpenStack, OpenShift, Kubernetes, and AWX, which is upstream for Tower. As a guy who's supposed to sell things, I'm supposed to mention the things that we're actually selling. And it's really hard to distinguish between projects and products. But from capability standpoint, they're one and the same. And so that's why the little bit of fudging there. But so you understand, I'm talking about what you get either way. Keystone has implied roles, and that's what I just talked about. I used the language of Keystone because that's how I wrote it, and that's how we discussed it. In OpenShift, you have this idea called aggregated cluster roles. So an aggregated cluster role is a role, or cluster role, that is built out of other cluster roles. And in AWX, or in Tower, we call these parent roles. So you have a parent-child relationship that you set up. So you have the mechanism available in all three of these layers. It's just called different things. But if you know that it's the same thing, it's this inference rule, then you can use a common way to think about it and to map things on out. And when we talk about namespacing, you can assign a role at the project level or at the global level. But that's not the same thing as the name of the role itself. If you want to define a new role, that's in Keystone and in OpenStack, it's a global namespace. We have a domain-specific namespace called domain-specific roles. And you have to use implied roles with those. A domain-specific role can't do anything by itself. But you could create a role called operator that maps to admin. And so anybody you assign the domain-specific operator role to would get admin there. And so you do have tools for building up your own name, especially if you're sharing a cloud between multiple organizations. On the OpenShift side, cluster roles are actually the global name. So that's the primary thing you're going to use. If you need to make something specific to a namespace, you can create a new role, and they're called roles. So that's confusing. Obviously, the two teams didn't talk to each other when they came up with this naming scheme, and we were first, so they were wrong. I take that back. I like the cluster roles name, but it's confusing. So understanding that they're different, but this is how they translate from one to the other is essential. And they operate differently. A domain-specific role has to link to a real role. A role, an OpenShift, which is really fine-grained, that can link to an individual operation. So I actually like that mechanism better, but we're not there right now. So at this point, and I've gone really fast. I was so worried about running out of time. I've run out of slides. So I'm going to open it up to questions, and we'll take it from there. And if we don't have a microphone, then I'll just repeat the question. But please step to the microphone. I have a question. Is the mic on? Can we get it on? Page 12. I can do that. I hope that's not the entirety of your question. I don't know if I can. Do I have page numbers here? They're at the bottom over there, yeah. I'm at that point. I need to take the glasses off to see things. Oh, OK, our Federation LDAP page, yes.
For this slide, my question is,
yeah.
Here, for example, for LDAP, we only get the user ID, or we get at the same time user ID and the roles?
Neither. Your question as asked, it gave me a false dichotomy. And what you actually get is something a little bit different. When you query LDAP from the LDAP code in Keystone, specifically, it's going to make two queries. The first is to get back the user record, And that's mostly just going to give you the user ID or the username. And you should never enforce policy. If you can at all avoid it on an individual user, you should always do it on some role in context. And the other thing you're going to get is a set of groups. Okay? Those groups are not roles. Okay? What you can do is say, based on a group, I can provide a role assignment. So anybody in the wears glasses and bald group can get that permission, right? I can't get that because I'm not bald. The wears goofy red hat group, any attribute you can get from LDAP, you can then do an assignment on. That will get you the roles, and that's what's going to be enforced on. So there's a layer of indirection in there. Okay?
Well, the problem that if we use the second option, means that groups, we translate groups to roles. And here we talk about federation. Imagine we have some users with groups in the first LDAP and others in second. We should do the aggregation. How can we treat the conflicts?
Awesome, good question. Everybody understand the question there? If we have two sources of identity that have different attributes that are coming in, that's a different set of groups, how can we do the assignments? And the reality is you're going to have two different sets of assignments, but they can be assigned to the same role. So say we have Pepsi and Coke, two different competitors, but they're both coming to the same cloud, and they both have their federation sources. And so one has in addition to their username, they have the name of the company they're coming from. So if you're in the Pepsi or you're in the Coke company, you should still get access to the soda project and member role on the soda project, or pop, or whatever you call it from where you're from. We used to call it tonic in New England. That's a dead term. So you would have two different mappings. The federation source, whether it's LDAP or whether it's SAML, will have the groups in it and have other attributes that you'll treat as groups. And so you'll map those to role assignments. And so you'll have two different role assignments. One based on, and they're probably going to end up being in different domains. And so you will have to manage those separately, but you have to. That's where you do
different domain or the same domain, it depends.
Okay,
in the same domain.
If you put them in the same domain and they end up with different groups, that'll probably work. If you can keep them in separate domains, it's cleaner.
In the same domain in this case.
Yeah, I would try to avoid that. But yeah, they could come from the same domain and have different sets of groups. You can have different groups with role assignments. Say you're talking to a single identity source and they're two different groups, but you want those to map to the same role assignment, you can do that. They're multiple role assignments, but the end effect is that they have that same role on the project.
Okay.
Does that make sense?
Yes, okay.
Okay.
And another
clear as mud? Too easy, shouldn't even be here? Okay, go on.
Another question, the slide 24.
Okay. Take the glasses off again. 24, okay. Yeah, the namespacing.
Yes, we are talking about the namespace. Or my understanding, for example, in Keystone, we have the roles which are global.
Yes.
And here, the namespacing of roles means we should put roles into different namespace.
So what I'm saying is if you want to be able to namespace roles, the only tool you have is domain-specific roles.
Okay.
So at the domain level.
Okay, means that one role in one domain is not visible for other domain.
Right, and so it has to map to some global role. Is it a great solution? No. Did it serve somebody's use case? Yes. Is that person still active on the project? Not as much as I would like. But it is a tool that you have. So I wanted you to know about it. It's probably good enough for most people's purposes, but it's weird.
Okay.
And so I just wanted to call that out. The Kubernetes thing is obviously serving a different purpose and is done differently. The commonality between them is they're both living within a namespace. So within a namespace, if you need to be able to customize, this is the appropriate tool. I didn't see something like this in the other services. There might be something like this in AWS, but I didn't see it there. And I don't think there's one in CloudForm or stuff like that. So,
for all of this, do we have a implementation or some code that we can implement these ideas, or just it's added?
This is how you customize post install. All this code exists. You know, I don't have a code base for this. This is how you address it when you go to solve the problem for your organization.
Okay.
Yeah. Thank you. Thank you very much. The chair recognizes the distinguished gentleman from?
From AT&T Chief Security Office. In an early slide, you talked about scope.
Yes.
Yay, scope is way important. What are we doing about that? Because I don't really have granular scope that I need. I want to authorize the rebooter for this part of the infrastructure to that role. I want to authorize the rebooter for this part of the infrastructure to a different role, because those guys shouldn't be rebooting these. And
those two things should be in separate projects if at all possible. Unfortunately, we don't have a way of classifying.
But even within a project, I need scope, and I don't have it. Are we moving towards that?
So I know that you were in our basic roles thing. So I'm going to jump ahead to like where we talk about the implied roles thing. And I think I just deleted my presentation. So you're probably seeing nothing right here. Slideshow. Start from current slide. OK. Hello, my name is Adam Young. No, old Andy Kaufman joke, especially because the slide I want is at the end. So let's talk about implied roles, because that's really the tool to get there. So say you want to treat a user in a project. Two different users should have different classes of access. One, perhaps to the network objects, and the other to the virtual machine objects, okay?
Or to specific network objects, or to specific
that I can't get you.
Objects.
That I can't get you. And I would argue that making that happen might do more harm than good. I know people want that, and there's other discussion that's beyond the scope of what I can do with the tools that I have for you here. You can do unspeakable things in policy, but you can't do them dynamically. So in order to be able to enforce policy that says that this user with this role can operate on this specific object, doesn't exist. There's not a clean way to do it in OpenStack today. And the ability to layer on those type of labels, because I know Kubernetes does have that. So we're talking specific to Keystone right now.
I get that we don't have it. I guess I'm just saying I really need it. So.
Well, so I hear you there. And there is a thing on labeling coming out in OpenStack, and I'm a little worried that people are going to use labels to do these kind of things, because then you need to own the label. And that's actually a really tricky thing. Who can label? So say you have two classes of servers, dev servers and production servers, and you have them in the same project, and you want to be able to distinguish between them. Who can own that label to say this server has the production label there? In general, if you need different classes of access, try to put those things in separate projects. And I understand Neutron makes that hard, because we need networking across these to make it work. And unfortunately, that's the security model of OpenStack today. So I would love to be able to get better sharing of resources across projects, so you have the same resource in different projects with different scopes on them, or they'd have to be different classes of resource. We don't have that.
For enterprise-style applications, this is the #1 thing that's driving us away from OpenStack and towards other solutions. For what it's worth.
Well, it's worth a lot. It's worth at least one AT&T deal.
It's my pretty jacket that was swag at another con.
Sure. Let's sit down and talk. Let's see if we can come up with a solution there. How many other people find this degree of granular access control essential? How many other people are asleep? Good, good. If you're asleep and you can raise your hand, you're strange. So where are we at on time? We have 6 minutes left. I see if there's any last questions here. Yeah, oh, thank you, thank you.
What do you use to test all of the various roles and rules across your sites? So
I can only answer that for OpenStack, because I don't know the tooling on the others well enough to know if there's comparable things there, but I do know a lot of people ask that for OpenStack. And so the first thing I will say is, in an offline manner, there's command line operations for also policy that says, here's my policy file, here's a mock auth context. Like somebody went to Keystone and got a token, the data there. Let me try it against a specific API, or actually it's going to be the policy thing, so compute : whatever. What would I get back? Or I could say run it against all, true, false type things there. So if you look through the, and I don't have it off the top of my head, that really should be in this presentation here, but I was trying to make this cross-cutting concerns. So I was trying to take off my Keystone hat.
The Tempest plugin?
Say again?
You use Patrol, the Tempest plugin?
So I have until recently been fighting against Patrol, and not because it's a bad idea, but because it's a good idea that could lock us into a broken policy. And what somebody recently got through my thick skull is that we can get Patrol into upstream gating so that it says that things are broken right now. And so that it's not going to lock us into bug 968696. And I know I say that just because you were just waiting for me to say it. If anybody isn't familiar with that bug, it's worth becoming familiar. It's the oldest bug in the Keystone. And because I keep doing work on it, it keeps getting reassigned back to me, even though I'm not supposed to be a full-time engineer anymore. Bug 968696 says that in a default policy in OpenStack, admin anywhere is admin everywhere. And if that sounds really bad to you, it's because it's really, really bad. And so if you're doing anything at all policy-wise, you're going to want to customize it, and there's ways to mitigate it. And so my goal with Patrol is that it goes green when we got that bug fixed. And so I went from being, don't put that in there because you're going to lock me into bad policy, to so this can be the tool that pushes us ahead. So Patrol is, do you want to give a quick blurb of what Patrol is? Because obviously that was a loaded question. I could see the gleam in your eye when you asked it, but I'm glad you did.
A Tempest plugin to call all the OpenStack APIs and validate that your role has the access to the proper APIs that you're expecting. Yeah.
Now that's OpenStack specific. Are we?
Yes.
Okay. So again, we're talking a lot of OpenStack specific stuff. Obviously, the same methodology we need across the board. Whatever your API is, whatever your exposed thing that your customers or end users use, has to be tested the same way. So you can have all the, there's a wonderful scene in The Simpsons where Smithers and Mr. Burns are going to run the power plant themselves. And they go through this full Get Smart style facial scan and down the bat pole and all these things. And they get to the end and they go through the last thing, and there's like a screen door flapping and a dog in the part where they actually run the nuclear power plant. And I don't want your security to be like that. Well, you have all this great stuff up front, and then there's a back door, a literal, in this case, back door into that. So yeah, Patrol will be awesome. That's only going to protect the OpenStack layer. You need to have that same methodology against all the layers. So if you're having Ansible, which is, so you have manage IQ call Ansible, which is calling Sahara, which is calling OpenStack to do blah, blah, blah. You need to have that same thing there. And you need to understand the structure of your RBAC to check that. Are there any other questions? Are there any other answers? Okay, so it was supposed to be. So my summary slide, and I was going to put funny pictures on there, but I couldn't quite match them on up there. The things I want you to take away from here is that roles are assigned in scope, and we'll try to get that scope to make AT&T happy in the future. But for now, just understand that it's not just the role that you have, but it's the scope of the resource that you have. And the policy is then repeatable. So you create a new project, you get that policy in place. That's the way you scale an organization. A little trust goes a long way. When you set up your automated systems, give as little trust as possible to each of these so that you don't accidentally give away the keys to the kingdom. And finally, create a hierarchy of roles. Think about the big picture and how can you break that down finer and finer over time so that when you do give away that trust, you're giving away just that minimal part. I'm Adam Young, and I endorse this message. I need the TED music to go in there to close it on out. Thank you all for coming.